So I have some data. I also have an original scatter plot here. So what type of relationship is there between foot length and height? Positive or negative? Positive. Linear or non-linear? I would say it's linear. Okay. What is the strength? Weak, moderate, or strong? Yeah, it's maybe hard to tell from eyeballing it. We're gonna calculate it in just a second, but I would say it's probably moderate. Okay, there's a little bit of variation there with the data points from the line of best fit. Okay, they also give me a residual plot. And so when I look at the residual plot, I see, is a linear model appropriate? Probably so. How do we tell? No real obvious pattern in the residual plot. Okay. And then they give me some output here. The predictors, I've got the constant and the foot length. And so the coefficient of the constant will give me the y-intercept. And then the coefficient of the foot length will give me the slope. So the first question here, it says, what is the equation of the least squares regression line that describes the relationship between foot length and height? Define any variables that you use. All right, so we are going to write down the y-intercept, which was 103.41. And I got that from the constant coefficient right there. And then we got the slope. The slope is 2.7469, so plus 2.7469. And then it says to make sure that we define the variables. So x in this case is going to be the foot length, and that is measured in centimeters. And y is what? I mean, you did raise your hand yesterday and you swore that you would never, ever forget to put your hat on, right? And then like 30 seconds later, you jilted your promise by reneging and forgetting to put your hat on. So I did it to you again, and it took you like 2 minutes to figure it out. Like, come on. Put your hat on. Well, debatable. Put your hat on. Why did I put the hat on? Because it's a linear regression equation, and it is the what? Owen, it is the predicted height measured in centimeters. Make sure that you define your variables. Okay. Interpret the slope of the regression line in context. So for each additional centimeter of foot length, okay, so we are interpreting what, I didn't put an X on there, did I? I need an X. It's 2.7469x. Right. I left that off in my regression line equation. Okay. And so interpreting that in context, this means for each additional centimeter of foot length, the least squares regression line predicts. What does it predict? It predicts an increase Why do I say increase? because the slope is positive, it predicts an increase of 2.7469 centimeters in height. And part C says, find the correlation. So how do I get the correlation from the output in the software? What is the correlation? Again, it is R, and they did not give me R, but they did give me what? They gave me R squared. Okay, so R squared, you're going to ignore the R squared adjusted. So R squared is right here, the 48.6. So I know that R squared is equal to 48.6%. And so that implies that R could be plus or minus the square root of 0.486. In this case, it's only the positive value. It has to be positive, right? Why? Because I have a positive slope on the original scatter plot and on the slope. The slope is positive. Okay, you just have to check though. If all you have is R squared, all right, it might be that the original graph, if you don't have it, is negative, as it could be. Okay, so this, if you put that into your calculator, you're going to get a positive 0.697. Slope is positive. And so this tells me that the strength between foot length and height is moderately strong. It's moderate because it's between 0.5 and 0.75. And the last question here, it says, is a line an appropriate model to use for these data? Explain how you know. Yes. A linear model is appropriate because what's the last part? There's no obvious pattern in the residual plot because the residual plot has no obvious pattern.